Hi everyone, I'm Gabriel Peterson, a developer evangelist at Arm. In this video, I'll guide you through the learning path, run a large language model chatbot with PyTorch using KleidiAI on Arm servers. In this tutorial, you'll learn how to request permissions and download the Meta Llama 3.1 model, launch an Arm-based AWS instance for running models, quantize the model to int4 using our open source KleidiAI library for PyTorch, run LLM inference on an Arm-based CPU powered by PyTorch and KleidiAI, build a browser application with Streamlit for the front end and Torchchat for the backend. I'll also demonstrate how to modify the provided program and commands to run Meta's latest Llama 3.2 model. Most commands can be copied directly from the linked learning path, except for the modified ones shown later in this video. Let's start by requesting access to Meta's Llama 3.1 and 3.2 models. It's best to do this first, as approval can take up to a couple of days. You can find a link to Llama 3.1 on the second page of the learning path, or go directly to Meta's Hugging Face page. Review the terms, fill out the required fields, and submit your request. This grants access to all Llama 3.1 repositories. To check the status, click the Your Settings link. Next, request access to any of the Llama 3.2 repositories in the same way. Once both requests are approved, you can proceed. Now, let's set up an Arm-based AWS EC2 instance capable of running the model inference. Go to console.aws.amazon.com, create an account or login. At the time of this recording, not all regions had our desired instance type, so I am sticking with US East, North Virginia, which I know has what we need. You can select the region at the top right. From the service menu, select Compute EC2. This is the EC2 dashboard. Click Launch Instance. Name your instance, and for the OS image, choose Ubuntu Server 2204 LTS SSD volume type. This is important to ensure compatibility with the required libraries. Select 64-bit ARM for the architecture. Choose the R8G 4x large instance type, as this is the Graviton 4 type the learning path was tested with. You can choose a different type, but make sure it has at least 16 cores and 64 gigs of RAM. Set up a key pair or use an existing one. Under Network Settings, either use an existing security group or create a new one. At this moment, the only setting you need is to allow SSH traffic from my IP. In the storage section, allocate 50 gigs of GP3 SSD storage. Once launched, go to the EC2 dashboard, select your instance, and copy the public IP4 address for SSH access. Remember, if the instance restarts, its IP address will change unless you configure it otherwise. And you'll probably want to shut it down when not in use because it costs around $1 an hour when up. Log into the instance using SSH with your key pair. After connecting, run sudo app update and app Then press Enter when confronted with the pink suggested restart screen. Install the required tools to get started. Create a Python virtual environment named Torchchat for running the scripts. Install PyTorch, Torchchat, and Torch architecture optimizations using the learning path commands. Override the installed PyTorch version with one optimized for Arm CPUs using KleidiAI. You'll need a Hugging Face access token to download the models. Follow the link in the learning path to create a new token with read access. If you haven't already, run the git config global helper store command. Then run Hugging Face CLI login and paste your token. Navigate to the Torchchat folder. In this step, we'll download Meta's 3.1 8 billion parameter model and quantize it to int4. We're using channel-wise quantization for better accuracy. This process can take anywhere from 10 to 40 minutes, depending on how quickly the model downloads from Hugging Face. Run the LLM using the Torchchat py command to verify the model is working. When prompted for a system prompt, type N or no. Test the chatbot with a question. While responses are cut off after 1 or 2 sentences, the browser implementation will handle full answers. To set up the browser-based chatbot, install the OpenAI version 1.45.0 package, as directed in the learning path. If you encounter the same error I'm about to have, we'll update this package to the latest version in a later step. Because I'm doing everything in WSL2 and the next step requires 2 terminals, I'm going to use tmux to do so, then activate the virtual environment in each pane. In one terminal, start the Torchchat backend. In the other, run the Streamlit frontend. In order for this to work correctly, you'll need to update your AWS security group to allow traffic on port 8501. Add an inbound rule for custom TCP, set the port range to 8501, and choose My IP as the source. Now, copy the external URL and paste it into your browser. If after writing in a question you get the same error that I have on the screen, stop the Torchchat and Streamlit scripts and run the command pip install upgrade OpenAI to bring it up to the latest version. Now, when running the Torchchat and Streamlit commands, your prompt should get answered correctly without errors. Now, the 8 billion parameter Llama 3.1 is great and all, but I am really a fan of Meta's latest Llama 3.2 3 billion parameter model, so I'm going to show you how to modify the program and commands in order to use it in this learning path. You can use whichever method you prefer for this next part, but I'm going to connect directly using SSH in the PyCharm IDE. Inside the directories Torchchat config data, there is a models.json file we'll need to add a new entry to. I'm going to place it after the last Llama 3.1 entry, and to get started, I'll copy and paste that entry as a template. Change the first line to match the Hugging Face Llama 3.2 repo, removing the second meta, changing the 3.1 to 3.2, and changing the 70B to 3B. For the aliases, we'll change it to Llama 3.2 tac 3B and Llama 3.2 tac 3B tac instruct. This is what the modified command we'll run soon after will look for. Change the distribution path to match the top line, and also it should match the Hugging Face repo. Change the transformer params key to Llama tac 3.2 tac 3B. This will be the name of a JSON config file we're going to create next. Navigate to the directory Torchchat build known model params. Either create a new file or copy and paste one of the other files and name it llama tech 3.2 tech3b.json. Fill it out as I've shown here. If you've copied one of the Meta Llama 3.1 JSON files, it will save you some work. While most of the keys are the same, many of the values are different, and there is an added hidden dim key and a rope scaling key. To make this new JSON work with our additions, we'll need to modify the models.py file, which can be found in the torchchat/build directory. At the top of the class, under Use Scaled Rope, add a line rope scaling optional dict and default it to none. Next, in the FromParams class method, right above its return statement, add if rope scaling in params, params rope scaling equals params.get rope scaling. Finally, in the setup catches method, place the fregs sys block in the else section of an if-else statement. Copy the entire thing into the if-self config rope scaling, but change the use scaled to equal true. Save and exit. Now we can run most of the same commands from before, but with slight modifications. For the download and quantize the model command, change the two entries that say llama 3.1 to instead say llama 3.2 tech3b. Because it's a smaller file, it should go quicker than 3.1. When you run the torchchat.py test command, replace the two llama 3.1 entries with llama 3.2 tech3b. Type no when asked for a prompt, and verify that it works as before. Lastly, as before, we'll start the Torchchat backend and Streamlit frontend. As you've done twice now, for the Torchchat backend command, change the two llama 3.1 entries to say llama 3.2 tech3b and then run it. Open your browser and paste in the external URL and try out llama 3.2. Thanks for watching. You can find a link to this learning path in the video description. If you aren't already a member, make sure to sign up for the ARM Developer Program and view other learning paths at learn.arm.com. Later.